Okay, so once again, good afternoon. In today's session, we are supposed to start with object orientation. That is to understand, we have to understand what is class, what is object, what are the object-oriented principles, how to work with object, why object orientation is so important. All concepts we'll understand. Okay, and from today, we will start using Eclipse. Fine. So let me just show you once again the quick overview of how to use Eclipse. In the last or previous sessions, we have already seen how to install Eclipse, how to download Eclipse, and how to work with Eclipse. But once again, I'll just recap it. Okay. Just after installation of Eclipse, you get this icon. Just click on this icon, double click on this icon. So basically, Eclipse asks you to browse the workspace. I have created a workspace called Europe workspace and just click on OK. The Eclipse opens. Once it opens, important, Eclipse comes with different versions. That Eclipse, separately you can download the Eclipse for Android. You can download Eclipse for J2EE or JEE, or you can also download Eclipse just only for Java. If you open, in my case, I have opened Eclipse. This supports J2EE also. You can see here the perspectives. It supports Java as well as Java EE, that is Java Enterprise Edition. So in such case, by default, it displays JEE, that is Java EE. You can switch to Java mode. Okay, you can switch to Java mode. So you should be able to see this navigator, or by default, it shows something called Project Explorer. Okay. So all these viewing panes you can get here: window, menu, show view. You can see navigator, package explorer, project explorer, different looking panes you can get. Since I'm comfortable with navigator, I use navigator. The same thing even you can get here using quick access. You can even get package explorer as well. Okay, but I'm comfortable with navigator, hence I use navigator. First step is to create a new Java project. Create a new Java project. I just call it as first demo project. Okay, let it use all the default settings. Just click on finish. Click on finish. By default, I get two folders. One is src and another one is bin. src is for source, bin is for binaries. That is, after compilation we get .class files. So all the .class files are stored in bin folder, and all the .java programs are stored under src. So right click on src source and new, you can select class. Okay, you can select class. Or if you don't want this, just control N, then N stands for new, select the class. Okay, it asks for something called package. Let us not use package because I haven't started with the concept of package, hence delete this. Just give only the class name. For example, my class name is demo. Okay, so now once you select the demo class, if you want public static void main, you can select this option. So automatically Eclipse provides a class called demo along with public static void main. Click on finish. We have got the class. By default it is public class. Public means the class is available for the entire application. That is the meaning. I'll repeat once again. When the meaning of public is the class called demo is available in the entire project. For example, think about this situation. I have one software or my project or application. In the project I have many classes. I have many classes. Okay, I have main method here, main method here, here also main method. So main method can be present in all the other classes. Okay, so if this class is public, then I can use it in the entire project. I can use it across the project. That's the meaning of public. If you don't make it as public, it can be accessed only within the package. So what is package? We will see in our future classes. Okay, as of now, what you need to really know is public means it can be accessed throughout the project. Throughout the project you can access. That's the meaning. Okay, now if you want to increase the font, you can just in the quick access type for font, just go on preferences. Here type for text, you get text font. That is, whatever the text that you type in this Eclipse, it is going to increase the font of that. Okay, I'll repeat once again. Here in the quick access, search for font. Once you search for that, in the preferences, click on this. Here you search for text. You get something called text font. Edit this text font, make it to whatever the font of your size. Click on OK, click on apply, click on OK. So it increases the font. Okay, so now I got this class with the main method. So if you want to delete any line, let's say this line number 8, the shortcut key to delete this line is Control D. You can delete this line number 5, Control D. You can delete this line, Control D. It's a shortcut. To save the program, you can save like this or Control S. Okay. To print something, just type this out. The help key is Control space bar. Okay, you can select this. It automatically prints. Here you can print demo program. You can save and you can run the program using right click, run as Java application. It prints the message demo program. The shortcut key to run this program is Control F11. Control F11. There are few shortcuts that we have understood. Control D to delete entire line, to delete the entire line. Control S, save. Control N, new file, right? Control F11, this is to run the program, run or to execute Java program. Java program, okay? So these are all few of the commands or shortcut keys that we can use in Eclipse. Okay, so from today we are going to use Eclipse and throughout our training session from today. Okay, good. Let's start with object orientation. Okay, very important. The moment when I say object orientation, many people they think that object oriented principles like encapsulation, polymorphism, and etc. But before we understand all these principles, we really have to know, before we know all these things, okay, before we understand these things, we really have to know what is object? What is really an object? And why do we need to create an object? What is the importance of this object orientation? Okay, so once you know the importance of this object orientation, your perspective will definitely change, and the way you look into your software development itself will change. Okay, so let's start our discussion with understanding of what is object orientation. Why do I need this object oriented programming language? Okay, then we will see to all the other principles of object orientation. First, what is software and why it is required? Think so many years back, maybe 100 years back, we people never used to use any softwares. There was no concept of softwares. After that, people started finding out softwares and all. Why it has happened? So think about it. Let's say, for example, 15 years back, not 15, 18 years back, 18 years back in India. This was the situation in India, approximately 18 to 17 to 18 years back, okay? Or maybe the situation in other countries as well, not only in India. If a person wants to, if a person wanted to withdraw money, all the way he had to go to bank. He had to go to bank, and in the bank official is sitting. A big queue is here. All the customers are standing in queue. You had to take a challan, fill that in the application, fill all your details, give the details to the bank officer. The bank officer gives you the money, and this was the situation, right? Just even if you wanted to withdraw even any amount, small amount to big amount, this was the situation. But now this is not the case. What do we do? Customer goes to ATM. Customer go to ATM. Once the customer goes to ATM, he operates on his own. So he tries to withdraw the money. He can request for checkbook. Even he can deposit the money in ATM machines. So that is all these operations made easy. The entire thing's made easy. So the nutshell understanding is this. If you want a software, basically a software is to automate the existing system. Software, what does it do? It ultimately, at the nutshell, it's going to automate an existing system, right? Because of this automation, the performance of the system increases, right? And can be accessed anywhere. The system can be accessed anywhere. Let's say I have an account in London, my bank account in London. To operate this bank account, I need not to come to London. Sitting in India, over the internet, I can access my account. This is the power of technology or the power of software. So basically the software is used to automate an existing system to improve the performance, and so that you can access the system from the different places. Correct? Now, in this process of software development, okay, if you take any software, it consists of, or it is an interaction of multiple objects. If you take any software or most of the software, it is an interaction of multiple objects. It is an interaction of multiple objects. Simple example. Let's say what is the meaning of object? Not the software meaning. In general, physically, what is the meaning of an object? An object is a real world physical existence. Physical existence. Okay. Anything which is physically existing can be considered as an object. It's a physical entity. I am using a pen. Pen is an object. I'm myself is an object. I'm using computer, which is an object. You are using your car for commutation. Car is an object, right? So anything and everything which is a physical entity can be considered as an object. Everything physically, whatever you see in this world, it is nothing but an object. So the meaning of object is a real world entity. That's the meaning of an object. Okay, now as like I was explaining you, okay, if you want to develop a software is used to automate real world or existing system, and your existing system or any existing system is a combination of objects, and many objects interact with each other. Simple example, let's say you are a software programmer. You are supposed to develop a software now, software for bank. Let's example Bank of America. Bank of America. So now you have to develop a software for this bank. Okay. First, what you need to understand is you need to physically go to this bank, understand how the bank works or understand the system. In this, what are the entities? Bank and lot of bank officials, customers. Customers has the passbook. Customer may have ATM card, right? Customer goes to bank, interact with bank officers, correct? Bank officer gives one application form to the user. Application form. This application form is filled by the customer, gives it back to the bank official. Like this, if you observe this entire system, lot of objects are interacting with each other. Customer is one object. ATM card is an object. The physical form which is given to this user for filling up is an object. Bank official is an object. Bank itself is an object. Correct? So here in this entire system, all the objects are interacting with each other. All the objects are interacting. So that's why if you use this object-oriented programming, and object-oriented analysis and design. So two things. One is object-oriented analysis, object-oriented design, then there is something called object-oriented programming. Three paradigms. Okay, if you understand these three, you can develop almost the software for everything which is present in this world. Now you think about any softwares. Okay, you go to airport. In the airport you are able to see a lot of softwares, right? The airport officials, they use a lot of different softwares. So what the softwares they use, right? So as and when the passenger goes, the airport official, they take your baggage. They're going to weigh this baggage, and whatever the details of this bag appears on their software. So he is the passenger. Passenger is one object. The bag is another object. The airport official, he or she is another object. Like that, they use multiple object, right? It is ultimately an object communication. So First thing what you need to do before you start with writing your Java program or object-oriented program. Object-oriented program can be written by using Java, Ruby, C Sharp, or different languages. Many more languages are there. Before you start with the actual program or actual application or actual software, what you need to do is first understand the client's requirement. The understanding the client's requirement, you need to understand the client requirement, or you need to analyze this client requirement. This is called object oriented analysis. First analyze what is required. But here you are not simply analyzing, you are analyzing keeping this OO in mind. When I say OO, it is object oriented. So you are analyzing the system keeping the objects in mind, or keeping the object as the context. For example, if I want to develop the software for this airport, okay, first I need to sit in airport and understand what are the problems that airport officials face, what are the problems that passengers are facing, okay, understand each and everything. For example, check-in section, security section, food section, passenger getting section, right, and flight arrival, flight dispatcher. So everywhere you see a lot of problems. So understand the problem keeping the objects as the context. So flight itself is an object, bag itself is an object. In the food section you see a lot of canteens, or you see a lot of hotels or cafeteria. That itself is an object. So everything is an object, and you understand and analyze the problems, and also analyze how existing system is working. That is called object oriented analysis. Okay, then you need to design the software. You need to really design the software. Again, this is the design part which I don't want to touch as of now. Okay, as of now let me not touch. You design the application keeping object orientation in mind, and then third step, you develop the software or you develop the application keeping this requirement and by using the design. Okay, generally this is, in simple words, this is like, you are writing your Java programs. Okay, so in our entire in this session, first let me concentrate on analysis, and also let me concentrate on design as well as development. Three areas we will see. Okay, but before that we need to really know about the basics and fundamental concepts of object. Okay, and lot of real-time case studies we are going to implement in these sessions, okay, in the object-oriented sessions. So in that, as the part of implementing that case studies, we are going to understand analysis, design, as well as OOP programming. This is object-oriented programming, object-oriented design, object-oriented analysis. Okay, if you think that I can simply write object-oriented programming without analysis and design, it is impossible. So clear? So when the existing system for which you are supposed to develop the software is a combination of many objects, or is an interaction of many objects, or the system itself work with the help of this lot of objects, and if I give you one technology which really helps you to develop the software or application using the context of this object, then what else you really want? What else you really expect? Correct. So use this technology which is very close to the reality, that is object word, and develop the software. Whatever you see, it is possible to develop the software. Okay, or in another word, in a simple way, let's say after 2 or 3 weeks, you should be able to, just after 2 or 3 sessions of our training, should be able to develop the software for whatever you see. Let's say you are walking on road. Just say you are walking on road. There is a canteen. In the canteen, a person is having some food. The person is having some food. You can develop the program for this. Okay, and you see another person trying to withdraw the money from ATM. You can develop the program for this. This happens in another 2 to 3 sessions. Whatever you see, you go to shop, bring some groceries, things, and you prepare the food at your home. And after preparing the food, you're going to have that food. You're going to serve the food for your family members. You can develop the program for this. So when yourself is so much comfortable with writing Java programs for whatever the real case studies that or whatever you see in your life, think you will be able to easily develop the Java programs for Selenium or for any other things. Technology does not matter because you know how to develop the Java programs for whatever you see. Whenever you are that much confident and comfortable, remaining things become very easy for you. Okay, so let's start the session with understanding what is object. Okay, so before that, any questions from anyone? Main question is, what is the importance of analysis and design? May I think about this? You're extremely a good programmer. You're a very good programmer. Okay, imagine you know how to write a program using Java. Assume, or in any other programming language. Okay, now I ask you to develop the software for share market, global share market.
Market is like stock exchange, you mean?
Stock exchange, exactly.
Yeah.
Stock exchange. You understood? So the
Yes, sir.
question is, you may be a really very good programmer, Java programmer. You know in and out of Java. You are master in Java. Okay, but only programming master in Java. Fine. Now, if I ask you to develop the software for the stock exchange, first thing you need to know how the stock exchange works or how the global share market works. Correct? Without understanding this, what software can you develop? Correct? So first, analyze this. First, you need to analyze this. Once you analyze this, we call it, you get a domain knowledge. Once you analyze this, you get the very good domain knowledge. Okay. Once you have this good domain knowledge, then you know exactly what is the requirement. Then you can develop the software as per this requirement. Otherwise, you will be developing some software which the people or the system don't want it. You never know whether your program or the software will exactly cater the needs or not. So understanding or analyzing the existing system is very important. Clear with this?
So after we find out the requirements of the software,
Yes.
then where does design comes in?
Yes.
What exactly is designing?
Okay, let me explain to you. Okay, let me explain
In
to
this
you.
context,
Yes, from the
right?
context itself I'll explain. Okay, I'll take one example, another example, then I'll come back to this context. Okay.
Okay.
Let's say you are a civil engineer. You are a civil engineer. Basically, you are into constructing the buildings and all such things, architecturing of the buildings, all such things. Okay. Now, a customer comes to you and he says that I need a house. I need a house. Okay. I need a house. Now, when he says he need a house, you ask what kind of house you need. This person says I need a house with 2 bedrooms, one kitchen, okay, one balcony, etc. He gives his specifications. He gives all his specifications and you develop a simple house, a nice house based on the specification given by this person. Clear? Now, imagine you have not planned properly to design this house, or considering this requirement you have designed the house and constructed the house. Very good, no doubt about it. Now in future, after 1 year, let's say this person again comes to you saying that, see, I want to construct one more floor on top of this house. There's only one floor as of now, so I want to construct one more floor on top of this house. Okay, this is his future requirement. Now you go and start constructing one more floor on top of this house, but at that time you come to know that this house has no pillars. This house, the already constructed house, does not have the pillars, or this constructed house does not take the load of one more floor. Then can you construct one more floor on top of this existing house? Not possible. So that's why the planning or designing of the house is very important. That once you design the house, before constructing you need to design this house. Once you design this, you need to consider the futuristic parameter, so that the house that you are going to construct as of now should be a generic house, so that even in future if someone wants or your client wants, you should be able to make or accommodate appropriate changes. So at the time of constructing this first house, if I consider the load and if I give enough space for pillars and all, even in future if this person wants, you can construct the pillar and have one more floor. You can construct one more floor. So this is called design. This is called design. From the example of house. Okay. Mayor, any questions?
I get it. Thank you.
If you want, I can give you more examples, or I can be elaborate on this.
No. I kind of understand the importance of design now. Just perfect.
Okay. Similarly, what happens with respect to software? When I develop any software, first it is not like you just collect the requirement from the client. This is a lot of disturbance. Just give me 1 second. Yeah, 1 second. Hello. Hey, just give me 2 minutes, guys. There are some disturbance here in and around. So just give me 2 minutes. I'll be back. Okay. Sorry for it. Yes, correct. Actually, for me here, I could see a lot of disturbance. Okay, huge disturbance for me. In fact, I'm not able to concentrate because of this. Anyhow, Mayor, any question from your end related to the design of the application?
No, no. I
Okay.
understand perfectly. Thank you.
Okay, fine. So, let's start with understanding what is an object is. Okay. So I just explained object is a real world entity. An object is a real world entity. Whatever you see, whatever you see in this real world, it is an object. Starting from laptop, starting from pen, your dress, your shoe, house, car, everything is an object. Okay. And if you observe the object, you could clearly differentiate two things. First one, second one. The first one is called the property of an object. Second one, a behavior. Second one is called as behavior. Okay. I'll just give you one example, you will understand. Let's imagine you see an object called car. You see an object called car. In this object, the properties are, we also call it as attributes. We call it as attributes. What are the attributes we can see in this car? The color of the car, model of the car, right? And then number of wheels in the car, the engine specifications of the car. Like that, you see lot of data or attributes or the properties in the car, starting from registration number, price of the car. They're all called as attributes. Okay. And when I say behavior, behavior is nothing but an action that you can perform on the object. What are the actions that I can perform on this object? I can start the car, I can drive the car, I can open the door, I can play the music inside the car, play the music. Like that, whatever the physical actions or the work that an object performs is called as behavior. Okay. Two entities. One is called property or attributes. Another one is called behavior or actions. So from now, any object that you observe, just as an example, okay, you should be able to see two things. Okay. Small example. Let's say your computer or your laptop. So laptop is another object. This laptop has some of the attributes. What are the attributes of this object? Laptop object, the model of the laptop, price of the laptop, specifications of this laptop, like what is the OS in this laptop, what is the memory of the laptop, right? What is the color of the laptop? So these are all called as the attributes. And what are the operations? What are the operations, or what are the work, or what are the behaviors that you can, or that the object performs. For example, the computer, you can play music, it performs basic computations, it performs basic computations, correct? It gives you a features like mathematical features, performing mathematical operations. You can play the game, you can play the game, you can draw image, you can do much many things, countless number of works that you can perform or this object performs. Clear? So any object you take, it has two things, attributes and behaviors. So it is not certainly mandatory an object can either have only attributes or it can have only behavior, or both attributes as well as behavior. So put together, this is the common characteristics of any object. Common characteristics of any object. Clear with this? Now, with this understanding, let us move on to a small concept of what is required for me to create an object. Okay. About a small situation. Able to hear me? You're unable to hear me? Not at all. Mir is saying not at all. Okay, fine. Oh, there's some, that message was for something else. Okay, fine. Think about this situation. Two examples I'll give. Okay, this this example is very important. Later I'm going to correlate the same example with Java. Okay, now I have to construct one house. I have to construct one house. Before me construct this house, can I call this as one object? It's a real world entity. This house as an object which is a real world entity. But before I could get this real world object, first thing I need to discuss, or I need to create a plan for this house. I cannot simply construct the house. Instead, first I need to plan for this house. I need to create the plan for the house. What is the area available for this house? In this area, what is the specifications? What are the different specifications that you have? I need to consider that. What should be the size of each room, right? What should be the size of each room? What should be the size of the staircase? Like this, the entire planning must happen. I may not be able to explain this in detail because I'm not a civil engineer, but a civil engineer or an architect understands your requirement and he will come up with the plan. While creating the plan, he also have to consider some government appliances because the government may have rule. This is the safety measures that must be present, right? Fire exit must be present in your house. It should be earthquake resistance, at least basic earthquake resistance. Like that, lot of other rules may be decided by the government. What should be the car parking space, maximum cars parking place? Like this, everything should be planned properly. And I don't know whether you have experienced or not. You want this physical house, you go to an architect, architect thinks, and finally he come up with the paper design. Finally, an architect come with the paper design or the paper plan. Once an architect or civil engineer gives this paper plan, and if you are okay with that, then this house can be constructed. This is very important. So what is first? First thing is your house. The first thing, we are creating the house, creating the plan. Second thing, second step is constructing the physical house. First is paper plan. Can I call it as a logical entity? The civil engineer
The
apply.
paper plan? The paper plan, you mean?
Can you come again?
You said, can you call the paper plan as a physical entity?
No, that also a physical entity because it's ultimately a paper, okay? But the content which is present on the paper is a logical entity. It comes from the brain of the civil engineer or an architect, right? So this paper plan, or basically, if you think in the other way, this is an actual house, this is not an actual house, or this is, I can say it's a virtual house, okay? Rather than calling physical or logical, you can consider this. This is a virtual house. Using this virtual house as the reference, or using this paper plan or the design or this logical entity as a reference, you are going to construct the house. If in the plan there are 2 bedrooms, in your physical house there will be 2 bedrooms. There is a staircase, here you will find the staircase. There's a big hall, you will find the big hall here. So this physical object is a replica of this paper plan. So a best word to call this as blueprint. Best to call is called as blueprint. This is called the blueprint or the plan or the design, and this is a physical replica which is derived from the blueprint. Are you clear with this? Now let's say one of the guests comes to your house. He's really impressed with your house, he really liked the house, and he or she also wants to construct the similar house. Now you give your plan to the same person. This person goes to his place and he also constructs another similar house. So the plan is only one, the physical objects are two. Like that, many people can construct the similar houses, correct? So this is the first step. What is the first step? Creating this virtual house or blueprint or the plan is the first step. Then you can create any number of objects from that particular physical plan. From that logical plan, you can create any number of physical houses, and this physical houses, we call it as object. And this plan, paper plan, or the logical entity or the blueprint is called as class. Okay, the object is derived from the class, and the content of this object are nothing but content of the class. Whatever it is present in a class, the replica will be present in the object. So without the class, you cannot create any object. So how many objects can be created from a class? Multiple objects. 0 to n number of objects can be created from the class. And class is just a logical entity, but the object is the physical entity. I don't know what is happening with the screen. Okay, I'll give you a second example to understand in a better way. Let's imagine you are running a business. A huge business you are running. Some business, some kind of business, okay? Some business you are running. For example, hotel business. And you want to really design, you really want a kind of visiting card or brochure. You want a brochure for your hotel. To promote the business, you need a brochure for your business. Okay. How many brochures you need? Maybe you need, let's say, 10,000 brochures. You need 10,000 brochures. Can I call each brochure as one object, physical object? Okay. What must be present on this brochure? Your logo of your hotel and main features about your hotel, right? What are the amenities available? What are the prices? What are the offers? Everything must be present in your brochure. You are extremely good in doing hotel business, but you are not that great in designing this brochure. Now what you do? You go to a designer. You explain your requirement. You tell him that, see designer, I'm running a hotel business. I want all these features to be designed, and ultimately I need a brochure which is very attractive brochure. Okay, so you negotiate what is the price and all with this designer. This designer now takes his laptop. Okay, he uses all the tools like Adobe tools or different tools he uses, and finally he design one brochure for you. Finally he designs one brochure for you. See, please observe, this is 1 in number. This is 1 in number. This particular brochure has your hotel logo, the menu, which food menu, offers, maybe some photographs of your hotel, all amenities, everything is present. But this is not the brochure, this is the design of the brochure. This is very important. This itself is not a brochure, this is just a design of the brochure. You or this designer gives this design to you. Now you have to take prints. You have to take multiple prints from this design. So how many prints you need? You need 10,000 prints. Whenever you get this 10,000 prints, can I say they are physical objects? Every brochure is a physical object which is printed by taking this design as the reference. So this design is called as a class, and this physical objects, that is printed objects, are the actual objects which are derived from this class. So that's why I call it as a logical entity. This I call it as a logical entity, and this I call it as a physical entity. Now how many objects I can create? If I give 10,000, I can create 10,000 prints. If I want 15,000, I can. But observe, all the objects, that is all the brochures, since they are derived from only one common design, they are all similar. They are all similar objects. Why they are all similar objects? Because they are designed or derived from the same design. They're derived from the same design. So this design, I call it as class, and these are all the objects of a class. So conclusion is that you cannot create any object without this class. And how many objects can be created? First you create one class, and later you can create any number of objects from this particular class. And all the objects created from the same class are identical objects. They're all identical objects. Clear? So without the class you cannot create any object. And the contents of this class or the design is the content of your object. That is, one instance is derived from this one. In this is one brochure is nothing but one instance of this particular design. It is something like this. On the full moon day, you could see moon, full moon. Okay, that day, imagine you have one bucket filled with water, and if you observe this bucket, you see one replica of this moon. You see one replica of the moon, correct? Similarly, keep 4 buckets filled with water, and if you observe this bucket, you see moon. So this is only one moon, but multiple replicas you will be able to see. In the same way, the class is only one, and an instance of the class. This is an instance of the class, instance of the class, instance of the class. You could see multiple instances of the same class. Any questions? Okay.
Yes, please. Thank you.
Yeah. So I really want to give one more last example. And in this example, I would like to talk some more things about the data members. Okay. So think about it. There is one IT company. Let's say IBM. One company called IBM. In IBM, there are lot many employees working for different organization, different divisions of the organization with different designation, different names and different email addresses, correct? Let's say there are few developers, 100 developers are there, 100 QA engineers are there, 10 managers are there. Okay, these many employees are working for IBM. Now IBM have to give or issue visiting cards. IBM has to issue visiting cards, or if not visiting card, there will be ID card. The ID card is supposed to be issued for all its employees, correct? Now can I call this ID card as one physical object? This ID card as one physical object. There are 100 plus 100 plus 10. 210 employees are working for IBM, hence 210 object must be created. Okay. If you observe all the 210 objects, when I'm telling this story, please try to visualize this. Okay. There are 210 physical objects that must be created. All these 210 objects may have the common look and feel or consistent look and feel. Here there may be logo of IBM. Please observe, and the here address of the IBM, phone number of the IBM, and contact number of IBM. This is, I'm talking about company details. Apart from that, it will have a place where your photo will be there, your name, along with your name, blood group, your name, blood group, and emergency contact. Emergency contact. These are all the contents of this ID card. So how many such, this is one object, okay? This is one object. Like that, 210 objects must be there, because 210 employees, every employee is given with one ID card, correct? 210 such ID cards must be present. Here one very important thing, some of the data in objects are same. Example, company name is one data. Does the company name change from your ID card to this ID card? May not be, because all are working for the same company. Hence here also it is IBM, and in all the other 210 objects it is IBM. Company name is same, company address is same, company phone number is same, and then email address is same. Now can I say all the different objects may share the common data? What are the common data? These are all the common data, but some of the data are really different. For example, photo, here the photo is different, individual photo name is different, blood group may be same or different, emergency contact different. So what IBM is supposed to do, IBM first they have to design a template of the ID card with their logo, with the address, phone number, email ID, everything, correct? So this is the template, or this is the design of the ID card. This I call it as blueprint. Now then, using this template or the design, they are going to create 210 objects. Okay, and this I call it as a class, and this object. So the objects which I have created is from this design called class. Whatever it is present, logo, address, everything is present. So these are all the common data which different objects shared from the same class. Okay. Also, apart from this, every object may have its own specific data. Okay, I'm just telling you, only data may be different, but entity is same. What is the entity? Name. Here also name, here also name, but the what name, the data change. Here it name may be John, here name may be Michelle, right? Blood group may be O positive, blood group may be B positive, but blood group must be there. So this I call it as the entities or the attributes. Please observe, the multiple objects which are derived from the same class share the same attributes. This is very important. And any number of objects can be created from this class, and multiple objects which are created from the same class has the same entities or same attributes, but the value of the attribute may change. And it is also possible that some data or some attribute and the data of the attribute may be same, like IBM, address, phone number, and then email ID. Clear? Tomorrow, if some 10 new employees join the organization, they can simply create 10 more new ID cards from the same template. So this is called physical existence, or this is called physical entity, and this is called a logical entity. This is the correlation between a class and the object. So first step is to create a class which is a logical entity, then you can create a physical entity that is called object. Are you clear with this? Start recording. Okay, if I consider the same ID card example with respect to Java programming language, first step what I need to do is I need to create a class. Second step, we can create any number of objects. We can create any number of objects from the class. So we already know how to create the class. Write a class, okay, with a name for the class. I call it as ID card. ID card. What are the simple properties? Properties like company name. Now you can unmute your microphone. You can also participate. Okay, let us make the class interactive. Should I declare this variable or not? Should I declare this variable? Company name. Imagine you have to create 201 ID cards. Sorry, 210 ID cards, because 210 employees are there in a company. In all the company, in all the ID cards, company name is same. Correct? Can I call it as a data member?
I think no.
String. I declared this company name because when I create multiple objects from this particular class, on all the ID cards, I want the company name to be present. Correct? That's why I declare this. That's why I declare this. This is one variable. Also, on all the ID cards, I need or I expect the address, phone number, email. Address, phone number, email. Address, phone number, email. That's why I also declare string address. Some address, okay. Some XYZ London. Some address. Also string email address, info@ibm.co.uk. Okay, and the phone number may be a long value, long phone number equal to some phone number. Some phone number, okay. So these datas are fixed. These datas are fixed across all the objects that we are going to create. You create 100 objects, 200 objects, 500 objects. This data does not change. And what do we call such data which does not change? We call them as constants. We call them as constants. And how do we define the constant? We define the constants by using a keyword called final. Okay, let me practically write this Java program. Let me write a class. Class name is ID card. Please observe the naming standard or the naming convention is camel case. Okay, so I need to define some constants. Constants are data members. Some constants are data members. So what are the data members? String company name equal to IBM, right? Then address, email, the email, info at ibm.co.uk. Example, long contact number equal to, this is the contact number, just giving you an example. But these are all the datas which are constants, and constants are defined by using the keyword final. Constants are declared by using final, and as per the good practice, this must be in uppercase, and then contact. Everyone understood why it should be declared in uppercase? It is just a good practice. Okay, final data members must be declared in uppercase. Once I declare this final data members, the value cannot be changed. The values cannot be changed. Now come back to this diagram. Okay, what are the other data members that I should consider here apart from these data members? What are the other data members should I consider? Can I say I have to consider employee name?
Employee name.
Yes, I should consider employee name. What is the data type of employee name? String. Should I define any value here? Should I declare any value or any data here?
No.
Why no?
We can because that will be different for that name will be different for
Perfect.
person to person.
Perfect. So imagine here in the plan, I'm talking about this is the design. This is the design. Okay. Try to correlate. This is the design which is created in the computer, and print when you give it goes as a physical ID card. If you in this design, if you declare it as, if you declare the name, or if you assign the name, or if you assign the data into this, on all the ID card the employee name will be Shweta. We don't want that, correct? Because name is specific to individual. Name is very specific to individual employees. Hence, I don't declare the name here. Okay, I don't declare the name. So this is just a variable. Okay, similarly, blood group, string, blood group. Blood group also differs from one employee to other employee. Hence, I don't declare that. Lastly, long emergency contact. Emergency contact also one employee to other employee, it is different. Hence, I'm not going to declare that. Okay. So
To write position.
yes, you have to add semicolon.
Yeah, I mean position of the employee.
Oh, okay. Position. If you want, you can add position of the employee. If you want, you can add. It depends on your ID card design. Okay. In my ID card, my position is not printed. It is just like, you know, only my name, blood group, and the emergency contact. That's all. Okay. It depends on your choice. Okay. Just consider it as only an example. Don't be very realistic. Okay. String employee name, and I also consider string blood group. Observe, I'm not assigning any value because the value depends on one object to other object. And then long emergency contact. Emergency contact. Clear? No, these are all my contents of the class, but these are all typically, all these are called as okay, all these are called as data members. They're all called as data members, and these are all called as constants, and these are all called as variables. But put together they are called as data members. I have not introduced any functions in this class, just I'm talking only about the data members. Later we'll see how to write the functions or methods in these classes. Are you clear? Now I have created this class. Till now, any questions for anyone in understanding how to write a class, how to declare constants and these? Any questions? Okay, now I have this class. Okay, let me just copy this. I have the class. Okay, now next thing is I have to create an object from this class. I have to create an object from this class. How many objects I can create from this class? Any number of objects of your choice. You can create hundreds, thousands and lakhs or crores of objects. You can create millions of objects can be created out of it. Okay, now how to create an object from this class? Two things: how to create, where to create. First, let us understand only on how to create an object. Let's not worry about where to create an object. Okay, so how to create an object? The syntax for creating an object is class name, ID card, any name, I call it as ID card 1 equal to, this is very important, new, all are lowercase, new, and the class name. This is something called constructor. Let's not talk about it. Okay, class name and the class name. I'm talking about the name, that's it. Okay, with this parenthesis, this is actually called as constructor, which constructs the object. The name itself indicates this is the constructor which constructs the object, and this is the keyword which we use to create the new object. The new meaning create a new memory for this object. Okay, this is called as a reference. This is called as a reference. Class name, reference, new, again the class name. That is nothing but constructor. Class name and the constructor name is same. Okay, this is how I create an object. So this object, to create this object, I need this class. Without the class, how can I create an object? Impossible. Correct? So with the help of this class, I can create an object. That's why I said at the time of explaining that without a class, we cannot create any object, or to create an object, we need to have the classes. Now, what happens when you run this program? When we run this program, physically one ID card is created. I'm just explaining you. This is the meaning of it. Don't expect to run this program and expect some ID cards through your computers. Okay, this is just an example wise. This is an object which is a physical entity. The meaning of this is one object called ID card object is created. This ID card object is created from the class called ID card class. Hence, whatever it is present, all the constants and okay, this, okay, this is shared and this is shared here. So I call this as one instance of class. What is the class? ID card is the class, and this is called one instance of the class. That's why we call the object as instance of a class. Once we create this instance from this particular class, whatever member it is present, one copy of this entire data members is created here. I'm just telling you one instance or one copy of this is created. You remember the moon example which I have given? You have the actual moon and the bucket filled with the water. If you see, one replica or one instance is created. You create you keep another bucket filled with the water. You see another copy of the moon. In the same way, one copy of this data members, when I say data members, both constants as well as variable is created here. Clear? So example, entire copies will come and sit here. Okay, please observe this. One copy comes and sits here. So that's why I call it as instance of a class. One instance is created here. And this company name, address, these are all the constants which has the data, and these variables is assigned with the default value. What will be the default value for this? For the string, default value will be null. This blood group, the default value is null, and for long default value is 0. Remember, the default value depends on, I just write all the default values here. The default value depends on the data types. For example, for string, default value is null. For integer, default value is 0, and for long, default value is 0, and for float, the default value is 0.0, and for double, the default value is 0.0 again, 0. Okay, and like that for every data type. For boolean it is false. Okay, for every data types a corresponding default value is present. Since it is long is to accommodate non-numeric, non-decimal numeric, so hence it is 0. Clear? So this is what it's going to happen for one particular object. Similarly, this is for one particular object. Okay, this is for one object. Similarly, you can create any number of objects. You can create any number of objects. Now I'm going to create one more object. Okay, how can I create one more object? Okay, what is the code to create one more object? ID card class name IC2 equal to this name can be anything. Okay, name can be anything. New ID card class name followed by bracket. Okay, this is how we create another object. This is the second object. Once you create the second object, what happens? The same story. One more copy is created. One more copy is created, and can I call this as the data members which are already declared or assigned or initialized? There is a difference. Okay, see, when I say integer I, this is called a data member without initialization. When I say integer j equal to something, then say this is also a data member, but it is already initialized. This is not initialized, this is initialized. Okay, similarly, this is the data members which are already initialized, and these are all the data members or variables or data members which are not initialized, which are not initialized. Okay, so the initialized and non-initialized, basically all the data members are shared when you create an object. Okay, but the initialized data members has the data which is declared inside the class. Whatever is declared, the same data is present here. Okay, and if it is not declared or if it is not initialized, then it will be initialized to its default value. The default value is this, right? Like this, we can create any number of objects from a class. Any number of objects. Any questions? That's a kind of summary of today's class. We understood what is a class. It's a logical entity. Okay, and we can create any number of objects from a particular class. So objects are nothing but the physical entities, and objects are also called as instance of a class. Our class is a blueprint of the object. Class is the blueprint, and objects are the physical entities derived from the object. How many objects can be created from a class? Any number of objects, and multiple objects which are created from the same class share the common properties which are present in the class. So these are multiple numbers. That is, once I create one object, one copy is present here. If I create once again another object, one more copy will be shared with the new object. So if the simple question, if I have 27 objects, 27 times or 27 copies of the same variable will be present. Are you clear with this? It's very important. And we cannot create any object without the class. Next question, where do we create an object? That we will see. But as of now, just we have understood how to create the object.